So today we're going to start the factoring lessons. So yesterday what we did expand. So we went from the factored form to the standard form, or we went from the vertex form to the standard form, right? And we call that expand or expand. The opposite of expanding is called factoring. Void and expanding are the same thing, right? So the opposite of expanding is factoring. So if you want to think about what is factoring, if you want to go from standard form, you guys remember standard form is y equals ax squared plus bx plus c. And then you want to go to factored form, which is y equals ax minus r x minus s. So if you want to go from the standard form to the factored form, you're going to do the process that we call factoring. Okay? So the process right here is called factoring. There's three different ways to factor, or three different ways that we're going to learn in this course to factor. The one that you always have to start with, and you always have to ask yourself, that's the first question you always ask yourself is, do I have a common factor? So that's always the first thing that you want to factor out, okay? Is your common factor, if you have it. You don't always have one, okay? So a common factor is an expression that can be divided into each term in a polynomial. So let's think about this. So if you look at this example right here, 9x cubed plus or minus 15x squared plus 3x. If you're looking at all the numbers, can you see a common factor for all the three numbers? So common number that you can divide 9 by, 15 by, and 3 by. 3, yes. So I can divide all three terms by the number 3, and I will still have whole numbers, right? So if I divide this by 3, it's going to be 3x cubed. If I divide this by 3, it's going to be 5x squared. If I divide 3x by 3, I'm going to get an x, right? So that's good. So the number 3 is called a common factor because I can divide every single term by it, okay? Now you also have to look at the letters. If the letter is also common for all three terms, in this case I have 3 terms, if I have the same letter in all 3 terms, then I can also divide by that letter. Okay? So you see I have x cubed, I have x squared, and I have an x. So I do have x in every single one of them, right? So you always divide by the letter x, let's say in this case, but with the lowest exponent. Okay? So because this is x cubed, this is x squared, and this is only x, then I'm going to be dividing each term by 3x. 3 because we've already determined that 9, 15, and 3 are divisible by 3, right? And then x is because every single term has the letter x in it. So what I want you to think about when you see x cubed, you have x times x times x. Right? X squared, you have x times x, and x you only have an x. Right? So technically the only common factor here is only 1x. Don't write this down, okay? So when you come to simplify, what happens for the first one, which is x cubed over x? What do you get?
One cancels each other.
So 1 cancels each other, so what do you have left?
2x squared.
Why 2?
Because there's 2 on the bottom.
don't worry about the 2 for now, don't worry. So what do you have here if you have, in this scenario, what do you have left?
Just 2x.
So x is multiplied together, what does that give me?
X squared.
X squared, right? If you simplify here, the x and the x cancel, then you're left with x. And then if you simplify x and x, what are you left with?
1.
Yana?
Yeah.
What did you say?
1.
1. It's a 1. Anything you divide by itself, it's a 1, right? So if I have 10 chocolate and 10 of you, you each get 1. You don't get nothing, right? And this is where the common mistake happens. Is students, when they divide something by itself, they think it's a 0. It is not, right? It's a 1. Make sense? Okay, good. So basically when I come to divide 9x cubed by 3x, what am I going to get? What's 9 divided by 3?
3 squared.
3. X cubed divided by x is x squared. So I'm going to be left with 3x squared. Okay? So let's see the steps that we have to do. So we've learned that the greatest common factor is going to be 3x. So what you're going to do is you're going to pull that 3x out. So you're going to write it outside. You're going to open the bracket. And then you're going to write the terms. And you're going to divide each term by whatever you pulled out. So you see what happened? I decided that my common factor is 3x. I pull it outside, factor it outside, open a bracket, and divide each term by it.
Why do you write like 3x in before bracket? Yeah. It means multiplication.
Because that's the one, so that's the one that you factored out.
Okay.
That's your common factor, right? So basically, I'll show you what happens now. Okay? So let's see what happens here. If I actually simplify, because I can't leave them like this, right? So 9x cubed divided by 3x, what did we say it is?
3 squared.
3x squared. Now, negative 15x squared over 3x.
Negative 5x.
Negative 5x, because 15 divided by 3 is 5, and x squared divided by x is x. So that's negative 5x. And then what did we say 3x divided by 3x is?
1.
Positive 1. Good. So basically, this is factored. Okay? So I took out the common factor, and then this is, I call this the leftovers. Okay? So if you want to go backward, which we're not going to do here, but if you want to check your work and make sure that you have done it right, simply you can distribute that 3x in, right? So you can multiply the 3x into each term, and you should get exactly what you started with. So 3x times 3x squared is 9x cubed. 3x times negative 5x, that's negative 15x squared. And then 3x times 1 is 3x. That's what I started with. Is that correct? Okay. So this is just to check your work. Don't write this down because I'm going to have to erase it. You want to put it on the side, okay? So my answer to this, when the question asked me to factor, right? I look, I ask myself, do I have a common factor? The answer is yes. My common factor is 3x because I determined that every term is divisible by 3 and every term have at least one x in it. So I can divide by 3x. Pulled out the 3x, divided each term by it, right? And then I have to leave my answer in this format. So my answer has to be left as 3x, so that's your common factor, times, in bracket, your leftovers, which is this. Okay? You can't drop your common factor. You can't just get rid of it. It has to stay there. Otherwise, this, your answer, and what you started with will not be equal. A lot of students ignore the common factor and they don't write it anymore, which is not correct. Because the minute you ignore it, then this 3x squared minus 5x plus 1 is not equal to 9x cubed minus 15x squared plus 3x. You guys agree with that? Okay, so that's why I must keep my common factor outside. That number, when it comes to the common factor, that number cannot be higher than the smallest number. Okay, so eyes on me, please. So if I look at this, 9x cubed minus 15x squared plus 3x, what is my smallest number in that whole triangle? 3, right? 3, the number. I'm just talking about the number in the chart. So 3 is the smallest number. My factor as a number cannot be greater than 3. Right? Because if you want to divide 3 by it, if it's 6, can you divide 3 by 6 and get a whole number? No, because 3 by 6 is a half. Right? So you can't divide by 6. The smallest number, right? It can't be, your common factor can't be greater than your smallest number. It can be less, but it can't be greater. And then with respect to the letters, you have to have the letter in every single term, and you take the one with the lowest exponent. Okay? Let's look at an example.
Common factor is 4.
Sorry?
4x squared.
You guys are ahead of the. Okay, I haven't even read the question. Good. Okay, so we have 8x to the power of 4 minus 4x cubed plus 20x squared. So look at the number and decide what will be your lowest common factor for that. 4. That's right, because 8 is divisible by 4, 4 is divisible by 4, 20 is divisible by 4. Right? They're all divisible by 4. Good. Do I have any common letter?
Yes.
X. What would?
X squared.
It will be x squared, because x squared is the lowest exponent. Make sense? Okay, so that means my common factor is 4x squared. You're going to open bracket, and then you're going to divide each term by 4x squared. So what do we call the 4x squared?
No, why is this one squared and the 3x wasn't?
Yes, because if you look at your exponents here, this is x to the power of 4,
Yeah.
this is x to the power of 3, and this is x to the power of 2. The smallest power for the x is 2, so this is the one that you factor out. Okay? If you look above, the smallest exponent for the x was 1. So that's why we will only factor it in. So the answer for this, can you guys do me a favor? Once you start something like this, always start your sentence or your line. We call it a sentence, started with an equal sign. Okay? So if I do 8x to the power of 4 divided by 4x squared, what do I get?
2x squared.
2x squared, that's right. So you guys notice, we'll talk about it in a second. What's 4x cubed divided by 4x squared? Negative x. The 4 and the 4 they cancel. X cubed over x is x. 20x squared over 4x squared. Positive 5. Now, can I have your attention, please? Can you tell me what is happening? I know I've showed you mathematically why it's happening, but can you tell me if you're looking at x4 divided by x squared, you're going to get x squared. If you have x cubed divided by x squared, you're gonna get x, right? So what is happening? What can you do in order to know what your answer is?
We're reducing when we want to know what is the answer, we're multiplying.
So what are you doing with the exponent?
We're dividing.
Okay, reducing means, when you say reduce means what?
Make it lower.
How?
1 times 2 is 2, 2 times 2 is 4.
It's not multiplication. So let me show you something. If I have x7 over x2, I get x5. This is what I get. Okay?
Subtract your exponents.
That's right. So you're subtracting your exponents. Is that okay? This is very, very, very important. Okay? So what's happening is, look at this. We're going to learn a whole unit on exponents and how to simplify exponents. Okay? But look at this. If I have x7, that means I have x times x times x times x times x times x 7 times 3, 6, so 1 more, divided by x to the power of 2. Right? This is what I have. This is basically this expanded though. Do you all agree with that? Okay. Now if I want to simplify, I have to eliminate, right? So I have to get rid of common things. So I'm going to get rid of an x and an x, and I'm going to get rid of an x and an x. What do I have left?
That's 5.
It's not 5x, it's x to the power of 5. Okay? 5x, if you're adding them, then they become 5x. When you're multiplying them, they become x to the power of 5. So you see, it's the same thing as doing this. Right? So it's the same thing as subtracting your exponent. Because 7 minus 2 gives me 5. Okay? Because I had 7, got rid of 2, I'm left with 5.
It's a kind of rules one, right?
These are rules, and these are called the exponent laws. And one of the exponent laws is the quotient rule, which is, we just did that. And it's when you have the same base, you subtract your exponent.
Yeah, the same base in multiplication form, you add them, and when you
That's
have
right.
the same base
That's
in
right.
division, you subtract them.
That's right. We're going to learn a whole new unit on that, but at the same time, these are things that you need to keep in mind when you're factoring. Okay? So you see right here, can I erase this? So if you see right here, when you say reduce, you're subtracting, right? So x to the power of 4 over x to the power of 2. If I do 4 minus 2, I'm going to get 2. So that's why I have x squared. When I do x cubed over x squared, 3 take away 2, that's 1. And when I do x squared over x squared, that's going to give me an x to the power of 0, which is 1. Like the whole thing. When you have something to the power of 0, that's another rule, that's 1. Okay? Anything to the power of 0 is 1. You can try it on the calculator. You can put as big of a number and as weird of a number in the calculator, make it to the power of 0, the answer is going to be 1. Okay? So, is this done? Yes. Yes. It's factored. I have my greatest common factor on the outside, my GCF, and I have my leftovers in that bracket. Good. Let's look at B.
5. Common factor is 5x.
So, what can you divide both 25 and 100 by?
25.
25. Right? Yes, you can divide them by 5, but that's not going to be your greatest common factor. That's going to be a common factor. 5 is a common factor. And just don't write this, please. So I can do this, and I can divide each by 5, right? And I'm going to get 5x squared minus, what is that, 25, right? But I still can factor something else, right? Because 5x squared minus 25, there's still another common factor that I can take out. So that's why we always say GCF, which means the greatest common factor. It's not enough that it's a common factor, it has to be the greatest one of them. Okay? So it's the factor that you can take the whole thing out. You know what I mean? So So your greatest common factor is 25. Can I take an x out?
No.
No, because my second term doesn't have an x in it, right? So I can't factor. So that means I'm dividing each term by 25. And then I'm gonna end up with 25x squared over 25. What would I have? X squared, because 25 over 25, that's a 1. Right, they cancel each other. And what's 100 over 25?
4.
4. And that's I'm going to come back to this question after we do the next page. Okay? I'm going to revisit this question after we do this page, by the next page. Sorry. Are we okay with this? Now look at the next one and try to find out what would be your greatest common factor.
9x.
9x. I think you can factor something else.
15.
Try more. So, in order to find the greatest common factor, you're gonna start dividing the start with dividing the smallest number by numbers, right? And then it's gonna give you a whole number. There's other people who showed me one way to do it. Who did show me that? They do something, I don't know, I can try to remember it, but something about like putting the numbers and then trying to factor things out of them. So what can you factor out of this? I don't know. I wish, who was it?
That is the HCF method.
What's
Highest
it?
common factor.
It would be the same idea.
Yeah.
Yeah, but then they do it like separately and then they go and then they multiply all the numbers together to find their greatest common
Yeah,
factor.
exactly. That's the HCF.
Do you know how to do it? Do you know how to set it up? Because I forgot.
You can try.
Yeah, try it and let me know. Otherwise, you're gonna have to keep dividing the numbers. Now, it's a factor if when you divide by it, so if you divide by 4, let's say, and it gives you a whole number, then 4 is a factor. Okay? If you divide by 3 and it gives you a whole number, then 3 is a factor. Okay? But you're looking for the greatest one that divides both numbers. Yeah, that's the one. So what do you divide by? So what do you divide both by? You try to do 3 first. Yeah. So you divide. I think they do this. I don't know. And then they go 3. Can I divide both by 3? 7. 27. And what's 135 divided by 3? What is it? 135 divided by 3. 45. Okay. Then they're both divisible by 3. Can you try that? I think this is how they do it.
So 5.
So that's 9. What's 45 divided by 3? 15. Yeah? 15. Yeah?
54 divided by 3 is not 27.
54 divided by 3 is not 27? No, it's not.
It's 18.
That's right. 18 divided by 3 is 6, right? And then I can divide both of them by 3 again. So that would be 2, and that would be 5.
Yeah.
So then this is, you can't divide these anymore, right? That's it. So you do 3 times 3 times 3, which is 27. So your greatest common factor is 27. Oh, okay. Okay, because I asked what's 54. Okay, sorry about that. So what they do is, Luke, you probably want to listen to this. So what they do is they set it up this way because it's bigger numbers. It's not easy to find the number, right? So they set it up as the 2 numbers that I want to factor, and they start dividing by easy numbers like 2 and 3, okay, and then 4 if they have to, okay, or 5. Like mostly prime numbers, 2, 3, and 5, I believe. And then, but the number that they choose, like 54 can be divisible by 2, but it can't, 135 you can't divide it by 2. Okay, so that's why we did not pick 2. But both numbers are divisible by 3. So they divide 54 by 3, and that gives you 18, and 135 by 3, that gives you 45. Okay, and then they keep doing the same thing until they get to a number that can't be divisible anymore. Okay, so then they go, okay, 18 and 45. I can divide this by 2, but I cannot divide 45 by 2. So I can't use 2. Let's try 3. Divide 18 by 3, that gives you 6. Divide 45 by 3, that gives you 15. Okay, so it's good. I can use 3 again. Now I have 6 and 15. Same process. I can't divide 6 by 2. I can divide 6 by 2, but I cannot divide 15 by 2. So I can't use 2. I'm going to try 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So they get to a number, the 2 and the 5, you can only divide it by 2. 5 you can only divide it by 5. So there's no common factor anymore. So they stop, and then they go 3 times 3 times 3, which is 27. Okay? This is one of the methods I learned from my students. I usually go with just knowing the multiplication table and then knowing what I can divide by. Another way is you can actually sit down and try on the calculator a few times in order to get the calculation. So that being said, so 27 is my common number, right? It's my greatest common number. Now, and then what? The letter X, right, is common in both of them. So what would I take out? X or X to the power of anything? Just X. Now, can I have your attention for a second, please? Because the first term has a negative in it, okay, the first term is the one that has the exponent 4, I want to take out a negative as well. I don't want to leave that negative there. So instead of just dividing by 27x, we're going to divide by negative 27x. Okay? And the reason for that is because I have a negative right here, which belongs to the highest exponent. Okay? So I want to take out a negative because of that. So that means I'm going to have to divide each term by negative 27x. Sorry. This is going to become positive. How about this? That's right. Okay? So my factor is going to be negative 27x. And then if I do negative 54 over negative 27, that's going to be 2. x4 over x, that's going to be x cubed. Positive over negative, that's going to be negative. 135 over 27, that is 5. And then the x and the x cancel, so I'm done. So the extra thing that we did here is that we took also a negative out, so we factored out a negative. So our first term doesn't have a negative in it. This is going to be important when we move to the other factoring, which is the harder factor. Okay? Before we move on to the next one, why don't you guys try Page 5 in your homework booklet. I want you to try G, H, and I. G, H, and I.